Okay, in this lecture we're going to be going over homework problem 58 for the paired samples worksheet. I'm going to go ahead and read through this problem and then we will work through it step by step. The way that you should see it in front of you, you should not actually have any of this information right here, so I'll just go ahead and make that white so that way you can see it in the same way that I have it. So, a study was conducted to test the effectiveness of a juggling class before the class started. 6 subjects juggled as many balls as they could at one time. After the class, the same 6 subjects juggled as many balls as they could. The difference in the number of balls are calculated. The difference has a normal distribution. Test at a 5% significance level. So let's label a few things. First of all, effectiveness of a juggling class. This right here, we're going to, let's see, make a comment. Review, there we go, review, new comment. We've got the independent variable, okay? Essentially, you've got the treatment. The treatment is the juggling class. Before the class started, 6 subjects, so you've got this right here is the sample. 6 subjects juggled as many balls, so as many balls as they could at one time. So the count of this, the juggled as many balls as they could, this right here, the count is the dependent variable, which it is dependent on whether or not they have taken the class. After the class, the same 6 subjects juggled as many balls as they could. So once again, the dependent variable, the count of that, as they could. The difference between the number of balls are calculated. The difference have a normal distribution. Test at a 5% significance level. So this right here is the alpha level. So we've got a little bit of information here, and now we've got to do some calculations. First, before we do any calculations, let's go ahead and go through the decision tree to make sure that we know exactly what it is that we're doing and why we are doing it. Okay, so we've got the hypothesis testing decision tree here, and let's go through this just step by step. First of all, are we dealing with continuous data from a sample, or are we dealing with frequencies of categorical data? This one's actually kind of complicated because we are asking for a count of how many times they juggled a ball, but because we're actually dealing with different scores and averages, we're actually going to be doing the continuous data right here. So I'm going to highlight this because we're going to actually be dealing with the averages at the end and the different scores. So are you dealing with an example or examining the difference between a sample and a population, or examining the difference between groups? Once again, this is a little complicated because you're dealing with the same group, but you are dealing with the group at 2 different times, before the class and after the class. Therefore, you're dealing with 2 different groups. It's the same group, it's just at 2 different times. So the next one is are the same participants being tested more than one time? In other words, do you have 2 values that are being compared to each other? And the answer is yes. We've got before the class and after the class. Number of categories. We have 2, one before the class, one after the class, which brings you through this right here. And you can now do the null hypothesis testing 6-step process by going through the paired samples t-test, which is what we are going to be doing right now. So, coming back to this, we're going to copy all this information here, and we are going to put it into an Excel worksheet. Okay, so let's see here. Scratch sheet. We've got this Excel worksheet right here, and I'm going to delete this. The first thing that we need to do is we need to calculate the difference score. So in order to calculate a difference score, you need to take before and subtract after from before. So we're going to do equals before minus after, and that gives us a difference score. And just drag it all the way down, before minus after, before minus after, before minus after, so on and so forth. And then we're going to take the average of each one of these columns. Equals average. Gonna highlight that, there we go. And then just drag it down. So it gives us the average of after, gives us the average of before, and gives us the difference, the average difference score. The only one that we're actually looking at is the difference score. When we have paired samples, we can look at all of these as independent, but it's actually a lot better and a lot more accurate to look at the individual difference scores. It gives a lot more information and just a lot more accuracy. So we have difference scores for each subject. For subject A, we have a different score. For subject B, we have a different score. So we've got a total of 6 people who took the juggling class. They each have their before score, their after score, and their difference score. And for this test, the only one that we're technically looking at is the difference score. So let's go ahead and make the null and alternative hypothesis. So let's go back into this worksheet a little bit from there. So first of all, we already labeled the independent variable and the dependent variable. We did that right over here. And now we need to know, what is it that I actually want to know? Do students juggle balls more times before or after class? Well, let's take a look at this, just make sure. The study was conducted to test the effectiveness of a juggling class. So we have before class and after class. So do students juggle balls more after class? So this is one way that you can write it. But the problem with this is we are the first variable before is the one that we're actually writing the hypothesis for. So what we really need to be writing is, do students juggle less number of times before class compared to after the juggling class? So notice how I wrote that there. I said, do students juggle less number of times before class compared to the after? And the reason why I wrote it like that is because we're actually looking more at before than we are at after. When we write the difference score, it's going to be before compared to after. And so it's going to be written like that. So coming down here, what is the null and alternative hypothesis? If I am comparing before to after, do I think that before is going to be less than after or more than after? And the answer is less than after. So even though we're looking at the effectiveness of a juggling class and we expect that the after is going to be greater than the before, we also expect that the before is going to be less than the after. And so because we're putting the numbers in this order, before compared to after, we need to write it all in that way. So when we are looking at before compared to after, how do we write the null and alternative hypothesis? So the null hypothesis is going to say the average difference between the paired samples of before compared to after is going to be greater than or equal to 0. And so I'll go ahead and write that out. Okay, so I wrote, the difference in the average number of balls juggled by each individual class participant before class compared to after class will be greater than or equal to 0. And so that right there is the null hypothesis. And for the alternative hypothesis, the difference in the average number of balls juggled by each individual class participant before class compared to after class will be less than 0. Less than 0. And so it's just a small change. But this is how you write the null and alternative hypothesis. And in just a second, we're going to look at what is it that we're actually doing here. Because this is a little confusing we're comparing a mean of the difference scores to 0, and I'm gonna show you a picture of what that actually means in just a minute. Before we do that, I need to know though what is the level of significance. Right up here, we've got the level of significance of 5%, and then what is the test statistic? The test statistic is going to be t. And the reason why is because we don't have a population standard deviation, and we only have 6 observations, and I'm going to go ahead and make these appear again. So we've only got 6 observations here. So therefore, it's a t-score because we don't have a population standard deviation, and we only have 6 observations. Then also, because it's a t-score, what's the degrees of freedom? The degrees of freedom is going to be 5. So how do we find the critical value? Because that's the next thing that we need to know is what is the critical value? There's a couple ways to find the critical value. First of all, the first way to find the critical value is by using the t distribution worksheet. So we've got the t-chart right here. And remember, we've got 5 degrees of freedom. And with our 5 degrees of freedom, we've got is it a one-tailed test? It is a one-tailed test. It's a one-tailed test, so it's a one-tailed test with an alpha of 0.05. So you've got your alpha of 0.05, and you've got your degrees of freedom of 5, so it's going to be 2.015. 2.015, more specifically, because we expect it to be less, it's going to be negative 2.015. So we've got that critical value right here from the t-chart. If it was a two-tailed test, which it's not a two-tailed test, but if it was a two-tailed test, it would be 2.571. 2.571. So what is it that we're looking at? And I'm going to use the 2.571 really quick. And the reason why I'm going to use the 2.571 is because with 2.571, we have the ability to make a confidence interval. We have a point estimate. The point estimate that we've got a point estimate of the average difference score. This average difference score, the negative 1.6667, is our best guess estimate of the average difference of how many balls an individual can juggle before class compared to after class. So that is our best guess estimate, and we want to know, is that best guess estimate, is it actually less than 0? Or do we have enough evidence to demonstrate that individuals actually juggle more balls after class compared to before class? Or do we have evidence to indicate that individuals juggle less balls before class compared to after class? So that's what we're doing here. So when we've got this 2.571, what we're going to do, I'm going to look at the standard deviation of the difference scores. So we've got the average, the mean of the difference scores is going to be negative 1.6667. And then the standard deviation equals standard deviation of the sample. And let's highlight that. So we've got the standard deviation. And now that we've got the standard deviation and we've got the mean, we can calculate the standard error. And the standard error is going to be equals the standard deviation divided by the square root of the number in the sample, which is 6. So this right here is the standard error, which I already calculated it down below, but I'm just going to get rid of that. Which now we can calculate our margin of error. How do we calculate our margin of error? The way that we calculate our margin of error is you take the two-tail crit value. So we've got this two-tail crit value. You take the two-tail crit value and you multiply it by the standard deviation, or better yet, you multiply it by the standard error. So now we've got the margin of error of 0.857. Okay, the margin of error of 0.857, and when we subtract the margin of error from the mean, that gives us the lower level, and when we add it to the mean, that gives us the upper level. So what we have right here is we are 95% confident that the actual pop mean falls between the values of negative 2.52366 and negative 0.809. Now the question is, let's home merge wrap. The question is, now that we have this range, this confidence interval, how does that actually compare to 0? Is it below 0? Is it above 0? And what is the actual probability of this confidence interval compared to 0, assuming that the null hypothesis is true? So that's what we're doing, is we're saying, hey, we've got this confidence interval. It's below this, it's below 0, so we know that it's different, but how different is it? How different is it? What is the probability of it being this low? And so we're going to be able to get a little bit more information about that. But this is what we're actually comparing. We're comparing this confidence interval right here to this value of 0 and determining if this value of 0 is inside the confidence interval or if it's outside of the confidence interval. And depending on what your answer is there, you're going to be able to determine the answer to whether or not you should reject the null hypothesis or fail to reject the null hypothesis. And so I'm just updating this information here. Standard error is 0.33333. And so we've got the margin of error, so on and so forth. So what is the decision rule? The decision rule, we're using the t-crit value. The t-crit value, which is negative 2.05, and also, so we're going to fail to reject, since it's a one-tailed test, we're going to fail to reject the null hypothesis if t-calc is greater than or equal to negative 2.015. So anything greater than or equal to this green line right here, anything greater than or equal to this green line, so, whoops. So anything over here, we would fail to reject the null hypothesis. Anything to the left of this green line, we will reject the null hypothesis. So that's the decision rule. And so we've got the t-calc. How do we determine t-calc? So we're going to come down here and we're going to calculate t-calc. So there's a few ways to determine t-calc, and this is the way that I'm going to suggest that you do it because it's easy and it's very accurate. Okay, so we're going to go to data and go to data analysis. And when data analysis pops up, you're going to go to the t-test for paired two samples for means. And we're going to highlight the before column, but don't highlight the mean. And we're going to highlight the after column. Okay, and we didn't highlight the difference score column, but the reason why we have the before and after is because they are calculating the difference scores for us. And so where do I want my output range? I want my output range right there. We're going to press OK. And now we have all the information that we need for the t-test. Okay, we've got the mean, we've got the variance for the before and for the after, and then we also have the information on the actual test. Another thing that I would encourage you to do is do analyze, data analysis, and do descriptive statistics. Press OK. And then we're going to do input range. And then grouped by rows. Output range, we're going to put right here. And then we've got all of our summary statistics, so on and so forth. And so now we've got the before. So this is all, let's highlight this. Okay, then this is after. And then this right here is the difference score. Okay, so before, after, and difference score. So if you want all of the information about that, the descriptive statistics will give you that. It will also give you this right down here is the confidence level, the 95% confidence level. In other words, this right here is your margin of error. Okay, this is your margin of error, and this is your margin of error. So this is your 95% margin of error. So when you run the descriptive statistics, even though we have the ability to do all the calculations ourselves by hand, we can also just run descriptive statistics and it'll give it to us, which is really cool. So we've got the kurtosis and the skewness, so on and so forth. So that's a lot of really great information there. Next, we've got the t critical value, the t critical value for a two-tail and for a one-tail. So you can check that against what we already did. And then more importantly, we also have the t statistic. So we could run the average difference score divided by the standard deviation divided by the square root of n minus 1. Or divided by n. So we could do that, or we can just run this. This is really just calculating a normal t-score, and so just be aware of that. But at the same time, we can just run this, and we'll get the -5. So we've got a calculated value of -5, and then we've got a t-critical one-tail test, or one-tail value of -2.015. Okay. -2.015, which is right there, and then the t-calc of -5 right there. So t-calc is below the t-crit value, so we already know we're going to reject the null hypothesis. And we're going to conclude that t-calc is below that the individuals juggle less balls before class than they do after class. Okay. So the critical value, because t-calc of -5 is beyond the t-crit value of -2.015, we reject the null hypothesis. Next, what is the p-value? Well, right here, we've got a couple p-values to look at. We've got a p-value for a one-tailed test and a p-value for a two-tailed test. This is a one-tailed test, so we've got our t-value, or our p-value right there. So p equals 0.002052. So in other words, there is a 0.2% chance that this would randomly happen, assuming that the null hypothesis is true. Okay, and I can write that out. Okay, so I wrote that out right there, and then the alpha is 0.05. Now if we compare the two of these, this allows us to know whether or not this is significant. Okay, because the p-value of blank is below the alpha of 0.05, the results of the test are significant and should be interpreted further. So what is our decision? Based on that, we're going to reject the null hypothesis. Why? Well, just look at the decision rule and state which decision rule applies. Because the t-calc of -5 is beyond the t-crit value of -2.05, we reject the null hypothesis. It's as simple as that. And then last but not least, we need to interpret it. Interpret your results in a way that you would tell your boss without using stats terms. Okay, so this is a really important part. And so what we would tell our boss is the average difference from before to after in the amount of time students are able to juggle balls is -1.6667. This difference indicates that the class appears to be effective in increasing the amount of time students can juggle. The probability of this happening by chance is less than 1%. So this right here, the probability of this happening by chance is less than 1%. I could put is 0.02%, or sorry, is 0.2%, but it's just a lot easier and a lot to understand. You know, the probability of this happening by chance is less than 1%. That's pretty standard for, you know, the way that we say things. It's less than 1% or less than 0.01%. It just it's the way that it's set. Therefore, we can be very confident, more specifically, excuse me, we can be 99.8% confident that this class is the reason why students are able to juggle more times at the end of class. So that right there is the interpretation. It gives information to your boss about what they need to know. There is, the difference score is huge. That's where the result is coming from. Okay. And so we'll come back to the very last one later. So the way that I have this set up, though, just to let you guys know, we just did this one together, and then I do want you guys to do this one. Okay, but then after that, everything else is just optional for you to have practice if you want it. You don't have to do it. So just be aware of that. I only want you to do 2, and then I want you to do the hypothesis, the final project one, and that's it. I don't want you to spend too much time. I feel like, we just keep on going through the same thing over and over again, which is this process of hypothesis testing, but hopefully by the end of it, you'll be really solid with it. So that's all we got for this, and I will come back and I'll do the last one a little bit later.